and this H is about 6 meters as well. So we want to find the force required at point A to keep the gate closed. That's our gate. Okay, as I just explained it, how we're going to solve this one, we have a 3-component contribute, right? So the vertical force, horizontal force, and also the weight of the water in this region. So I'm going to start with the horizontal force. So for the horizontal force, we know it's equal pressure times area, and the pressure is the pressure at point A. So it means it's equal rho g h1 times, and the area is the projected area in the horizontal plane. It's equal the width of this gate. Maybe I should also write down the information we have. The width is about 10 meters, the radius is about 6 meters, and we want to find out FA. So it's the width times H1 sorry, R, not H1. We know the density, that's the density of the water, times gravity 9.81, times H1 is 6 meters, and the area is 10 times 6. So the force is about 600 newtons. Now we're going to find it for the vertical plate. So for the vertical plate, we learn the force is equal rho g h bar times area, vertical area, which is the area projected on the vertical face, vertical face. So what's the h bar? H bar is the distance from the free surface up to the center of this vertical plate, imaginary vertical plate. So it will be rho g, and h bar is 6 meters, up to here is 6 meters, and this one is the 3 meters, times the area, which is the 10 times 6. Because it's the quarter of the cylinder, the projected area in the vertical plate or in the horizontal plate, they are exactly the same. If you just replace the value of the density, gravity, we can find the vertical force, which is about 52.97,400 newtons. That's the second one. And the third one is the weight of the water. We call it FW, and it's equal density times gravity times volume of the water in this region, which is a quarter of cylinder. 1000 times 9.8, and volume is a quarter of PR square times W. If you put all the values, we can find FW, and it's about 2773712 newtons. Okay, now we have all the forces, but what we're looking is we want to find FA. How we can find the FA? We need to actually write down the momentum around point B, because we want to find FA to keep the gate closed. So it means the moment around point B should be equal 0. If we write down the moment around point B, we have all the information except the FA, and that's the way we can find the FA. But before that, we need to ensure we know where these, forces are acting. Okay, I'm going to remove these. I'm going to just present that's the horizontal force. It's acting on the center of this surface, so it means the distance from here, we call it xh, and xh is equal 3 meters, right? It should be half of this length. This length is equal about 6 meters, so it's 3 meters. The second force is the weight, and we know the weight is actually acting at the centroid of this shape, which is a quarter of cylinder. We call this one xw, and xw is equal, you need to look at the slides provided in the lecture note or textbook. For the a quarter of a circle, it's about 4 times radius divided by 3 pi, which is 4 times 6 divided 3 times pi, and is equal 2.546 meters. The next force we have is the vertical force. We call this one H vertical, and that's a point B, right? This is the force FA, and we know this distance. This distance is equal H2, which is given, is 6 meters. The only missing, or the only thing we need to find out, is the HV. If we find the HV, it means we have all the information to write down the moment around point B. How are we going to find HB? Based on the formulation I just provided in the lecture notes. So, we know the formulation for the center of the pressure is the YP is equal H bar plus I divided by area times H bar. But just keep it in your mind, this is the HP for this vertical plate from the free surface. This is the YP, okay? Or if I want to show it here, this is the YP. We can find the YP from this formulation. We know the total height, which is about 12 meters, 6 meters this distance and 6 meters at the above. So we can simply say that HV is equal 12 minus YP. So we already know the H bar. H bar is about 9 meters. The formulation for the R is W times the H of the plate cubes divided by area, which is the W times H plate times H bar, which is 9 meters. Well, W's just cancel out, and we will have H plate square divided by 12 times 9 is 6 meters, square divided by 12 divided by 9, and the answer is about 9.333 meters. If we just put it here, it gives us HV, 12 minus 9.333. So the vertical distance will be about 2 meters, 0.67 meters. Now we can write down the moment around point B. The total moment around point B should be equal 0. Why? Because it's in balance, and we have to also consider a direction. It doesn't matter you're choosing clockwise or anti-clockwise. I assume the clockwise is the positive, and based on that I can write the formulation. We're using, the right hand rules. So for the FA, if you use our right hand rule, we're going from FA to the distance. It means, and our thumb shows the direction, okay? So FA times, or maybe it's easier if I just started from the, these forces. So for the FH, if you just look at that picture, you can see FH times XH plus FW times XW plus FV times HV. This should be equal FA times H2. Or if you want to keep everything at the other side, they give us, a positive moment, while this will give us negative moment. So I just bring it to the other side of the, equals sign. We know FH, we found it. We know FW, we know FV. The only thing is the FA. That's from this algebraic equation we can find. And FA will be equal 52.97 or 72 newtons. That's the final answer.